Okay, so question number 4, finding a confidence level from a given confidence interval. So based on our formula that confidence interval is equal to x bar plus or minus z critical times sigma over the square root of n. This problem is a lot different than all the others that we did because we're working the entire thing backwards. So all of the information that we have to fill in. So we have n, we have sigma, and we have to remember that x bar is right in the middle of our confidence interval. So the first thing I'm going to do is average those two values to find our our x bar value. So I got x bar is 15.205. So when I plug everything in, I have my x bar, I have sigma, and I have n. Now what we need to remember at this point is your critical value is directly related to your confidence level. So if we are trying to find the confidence level, that means at this point we don't know what our critical value is. Another thing that's a little bit weird about this problem is we have the plus or minus, which the plus or minus is what gives us our two ends of our confidence interval. So if we minus the margin of error, we get the low end. If we add it, we get the high end. So what you need to do for the purpose of this problem is you just need to pick one. Are you going to use plus or are you going to use minus? So I'm going to use plus, which means my result is going to be the high end of my confidence interval. So now we have an equation set up that we can just simply solve for z critical. So the first thing I'm going to do is subtract my mean on both sides. So I've got 0.635 equals z critical, and I'm going to go ahead and convert this to a decimal just for the sake of writing it down. And you can see what I've done here in my calculator. So now to get my z critical by itself, I need to divide both sides by this 0.473. But what I would advise you to do is make sure that you're using this value as accurately as you can. So use second negative to get the answer. So we have a critical value now of 1.342. So what you have to do now, we are used to going in reverse. We're used to starting with a confidence level and turning it into a critical value. Now we have a critical value that we need to turn into a confidence level. So what this means is we have negative 1.342 and positive 1.342, and we need to ultimately know this percent between our two critical values. So what we're going to do first is find this area to the left. So in all the other problems before, we had to use normal CDF, we had to use inverse norm, so now we're going to use normal CDF. So to find this area, I'm going to go from negative infinity up to my value, negative E99 to negative 1.342. We're still just using mean of 0, standard deviation of 1, because we're basing it on a standard normal distribution. So I get 0.0897. So I'm going to go ahead and say that this is 9%. So that means that this tail has to be 9%. So I now have a total of 18% used in the tails, which means I have 82% left on the inside. So that gives me confidence level of 82%. Okay, so now moving on to number 5. We have a car company talking about gas mileage for a luxury sedan, and this is going to be their sample mean, a mean of 21 miles per gallon. sample size. Oh no, wait, I'm sorry. This is their claim about their population. And then we have a sample mean of 19 and a sample standard deviation of 4. So first of all, choosing your confidence interval correctly, because we don't know the population standard deviation, that means this is going to be a t interval. So I'm going to go ahead and just use the calculator to create this. So stat test t interval, we have stats, not data. So their sample is 19. Their standard deviation is 4. 15 cars, 95% confidence. So I have 16.785 to 21.215. Now, for the interpretation, that means we're 95% confident that the true mean miles per gallon is somewhere between 16.785 and 21.2. So based on the results, does the car company's claim seem reasonable? And in this case, we have to say yes, because 21 falls into our interval. So maybe they're being a little bit sneaky and using the high end of the interval, but because 21 is in the interval, we can't rule it out. It is possible that it could be the actual mean. Okay, number 6. Of 1,012 high school softball players, 83 stated that they suffered an injury. So this is N, so 83 is my X. So for my confidence interval, stat test, because we are not dealing with means or standard deviations, we're dealing with percents of a population, so we're doing a 1 prop Z interval. 83 out of 1,012. Change my confidence level to 90. So what this tells me, my interpretation then, is I am 90% confident that the true proportion or the true percent of high school softball players that suffered an injury was somewhere between 6.7 and 9.6%. So if we want to do the margin of error, there's 2 different ways that you can do this. You can base it on the confidence interval that you have and the p hat value that was given, or you can do this by hand using the formula. So knowing that p hat has to be right in the middle, and the calculator is telling me that p hat is 0.082, if I want to find the margin of error, remember that's your wiggle room, or kind of your give and take from the point estimate to each end of the interval. All I have to do then is 0.082 minus 0.0678. So I get a margin of error of plus or minus 0.0142. So about 1.4% for my margin of error. So now what we want to do is we want to reduce the margin of error down to 0.5, and this is supposed to say 0.5%. So we want to make our margin of error from 1.4% down to 0.5%. So recalling what the formula is for your margin of error, it's plus or minus z critical times the square root of p hat times 1 minus p hat over n. So using this formula, we now want our margin of error to be so if it's 0.5%, we have to put 0.005. And my critical value for 90%, I've got to calculate. So 1.645. Then my p hat was 0.082, 1 minus 0.082, and ultimately we are trying to solve for n. So now you just have to use your algebra skills to solve this. And remember, on these problems you get a lot of really crazy decimal values, so the more you can do and keep in your calculator, the better. So I always write things down just to know where I'm at in the process, but I'm going to use the calculator to maintain the entire value. So at this point, to get rid of my square root, I have to square both sides. So I'm going to square that answer, and now you notice we get some pretty nasty scientific notation. So this is equal to, let's see, I'm going to do 0.082 times 1 minus 0.082 divided by n. Okay, so now I'm going to multiply both sides by n to cancel that out, which means ultimately I have to divide this value. So I'm going to take my answer divided by this awful scientific notation, and because we are solving for sample size, we can't have part of a person, so we always round our sample size up to the nearest whole number. So if we wanted to get within 0.5% with our margin of error, we would have to have a sample size of over 8,000. Okay, so I'll stop this one and I will start a new video for problem 7.